Hey everybody, we're back and today we're talking about the quadratic formula and the discriminant. And I am so excited to show you this because the quadratic formula is kind of that thing that it's not once in a while this will work or sometimes it works. The quadratic formula works every single time, no matter what, for any quadratic equation, okay? So here's what you need to know about it. You can use this to solve any quadratic equation. Any one at all, ones that factor well, the ones that don't factor well, the ones that have an a term bigger than one, not bigger than one, all of the above. The quadratic formula works every single time, no matter what. And so as a mathematician, this is what I use almost every time without fail because we know it always works. And this is also one of those instances that I'm going to sing to you because there's a quadratic formula song. And here's my suggestion to you. Either learn this song or look it up on YouTube and learn a different version of the song. But definitely learn the song because you'll remember it so much faster. So here is the quadratic formula. It goes like this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So you probably recognize it, that it goes to the tune of Pop Goes the Weasel. And it just really helps us remember. So again, here it is. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And if we were in class right now, you'd be singing that with me at least 5 times because 7 times is the charm. If you can do that 7 times, without looking, you've got it forever. And I still have students that I had in high school come back to me in college and sing me that song. So they will remember it. They can remember it, so can you. And I promise you will be using this throughout college as well. And remember that this comes in terms of when we have the quadratic formula, ax squared plus bx plus c. Keep in mind, this is our a term, this is our b term, and this is our c term. It never has an x in the a, b, or c. It's just what's in front. Okay? So for example number 1, let's just say they asked us to solve x squared plus 3x equals 2. In order to solve this using the quadratic formula, remember when we said solve, set it equal to 0, which means we're going to subtract the 2. Subtract the 2, set it equal to 0. So now we have our a, b, and c terms. Our a is 1, b is 2, b is 3, c is negative 2. So a is 1, b is 3, c is negative 2. Write that so that when we write down our quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. When we go to plug that in, all the numbers are right here. So we go negative b, which is 3, plus or minus b squared minus 4 times a times c all over 2 times a. When we do that, we just now literally you just do the math. Go ahead and do what's inside that root first, okay? So negative 3 plus or minus the root of, this becomes 9 minus 4 times 1 is 4 times negative 2 is negative 8. So that's our plus or minus. And then put everything over 2. So we get negative 3 plus or minus the root of 17 over 2. And that is our answer and we've got 2 answers for that. Okay. What happens if, well, we'll get into more examples when we get to class, but for now, I just wanted to show you the quadratic formula. And now we're going to learn something about the discriminant. So the discriminant is a part of the quadratic formula. So here's our quadratic formula that I showed you already, right? Here's our quadratic formula. The discriminant is this little piece inside the root, the b squared minus 4ac. So again, the discriminant is just b squared minus 4ac. It's the stuff under the square root. And here's the thing. When we look at the discriminant, there can be 3 values of a discriminant. Once we put the values of a, b, and c in, it could be positive, it could be 0, or it can be negative. And whether or not it's positive, 0, or negative tells me different information about it. If the discriminant is positive, it tells me there are 2 real solutions. Okay? It tells me that there are 2 real solutions. If it's 0, if the discriminant is 0, it tells me that for that quadratic equation, there is 1 real solution. And if it was negative, that tells me that the quadratic equation has 0 real solutions, but it has 2 imaginary solutions, okay? And here's what this looks like. If I was graphing the positive discriminant, and here's what it would look like. If I had the parabola, it would look like this, where it actually hits the x-axis twice, where it has 2 x-intercepts. For the next one, if I were to graph that, I would have 1 real solution, which basically means it only hits the x-axis once, and it has 1 x-intercept. And then the last one will never hit the x-axis, so it has no x-intercepts. Okay, so keep that in mind. Our discriminant comes from the quadratic equation, but the discriminant tells us several pieces of information that we need to know about our quadratic equation. So let's look at this example. If they said use the discriminant and they want us to tell if it has how many solutions it has, so tell me how many solutions it has, and the type. Okay, so here we go. We're going to list off A, B, and C. So here's C, here's B, A is 1. So A equals 1, B equals -8, C equals 17. And keep in mind, we're still going to need to use our x equals -b plus or minus square root b squared minus 4ac all over 2a. And we're just looking at this part. So b squared is 8 squared minus 4 times a, which is 1, times c is 17. So if we're looking at that, we've got 64 minus 4 times 1 times 17 gives me 68. So if I go 64 minus 68, we get -4. Now, that is our discriminant, which are not solutions, but they tell me about the solutions. So because it's negative, we know that there are 0 real solutions, but 2 imaginary solutions, okay? And they're imaginary. So there's 0 real and 2 imaginary solutions. And then the nice thing is, what if they asked you to solve this? If they asked you to solve it, what's cool is you've already done so much of the hard work. Remember, to solve it, we're going to go back to the quadratic equation here in green. And we would say, okay, x equals -b, which is -8. So we go -8 plus or minus the root of, well, if this is the discriminant right here, isn't the discriminant -4? So that's what I'm going to put right here because we just found the discriminant. all over 2 times a, which is 1. So once you found the discriminant, you can solve so easily. We're going to add the opposite. We get 8 plus or minus. The root of negative 4 is really, remember, the root of 4 times the root of negative 1, which that root of negative 1 is really I. So we get 8 plus or minus the root of 4 is 2, I all over 2. And then we simplify here, and we simplify here. So 8 over 2 is 4, plus and minus 2 over 2 is just 1, and 1 times I is I. So that's our solution for x. And we already knew because the discriminant said that we had 0 real solutions and 2 imaginary solutions right here. And see, now we've found them. And that's it for section 8.